In my previous video, I demonstrated how to determine the zone time of sunrise, when our vessel was anchored in Anchorage Area Number 7, San Francisco, USA, on 19th of December, 2021, a date that falls in the middle day of the daily page of the Nautical Almanac. In today's video, we'll calculate the zone time of sunrise for the following day, which is the 20th of December, when the date is not in the middle day of the daily page of the Nautical Almanac. The ship remains at the same anchorage area, with the same position. This is what we obtained in my previous video, when we calculated the zone time of sunrise. If you are new to this channel, and you want to know the full details of this video, kindly check the link in the description below. Before we proceed, let's first take a look at the daily page of our Nautical Almanac. In the upper right corner, we can see that this page covers 3 days, December 18th, 19, and 20, of the year 2021. We can find the local mean time of sunrise and sunset here. The data here is in the middle day of the daily page, which is December 19th. Since we need to find the zone time of sunrise on 20th of December, which is not in the middle day of the daily page, an additional step is required compared to those in the middle day. Our first step is to extract the local mean time of sunrise for the given date, from the daily page of the Nautical Almanac, interpolating for the observer's latitude if necessary. Since 20th of December belongs to this daily page, we will use the data of sunrise on this page for our first step, which is 19th of December. If you've already seen my previous video on this topic, feel free to skip ahead to the second step. Now, we need to find the time of sunrise for this latitude, but it has no exact value in here, so let's interpolate. The time of sunrise at latitude 35 degrees north is 07 hours, 03 minutes. In latitude 40 degrees, 07 hours, 17 minutes. To interpolate, you can use any method you are familiar with, such as using a calculator or an Excel sheet for faster results. The method that I'll show you is manual interpolation. The difference between these two latitudes is 2.18 degrees, and the difference between latitude 40 and 35 degrees is 5 degrees. Be sure that these values have the same units, which are in degrees of an arc. For those who are confused about how to get 2.18 degrees, just convert 49.41 minutes into a fraction of a degree. Divide 49.41 minutes by 60, since 1 degree is equal to 60 minutes. This will become latitude 37.82 degrees. By subtracting it from latitude 40 degrees, the difference is 2.18 degrees. On the other side, the difference here is unknown, so let x well be our unknown. The difference in the time of sunrise between latitude 40 and 35 degrees north is 14 minutes. So we can now have an equation: 2.18 degrees divided by 5 degrees is equal to x divided by 14 minutes. Cancel both units of degree, and cross-multiply. Then transpose. The value of our unknown is 6.104 minutes, or 6 minutes, 6 seconds. To find 6 seconds, multiply 0.104 minute by 60, since 1 minute is equal to 60 seconds. So this is now the value of our x. We need to determine whether we will subtract or add it. Looking at the time of sunrise at latitude 40 degrees, going down to latitude 35 degrees north, the time of sunrise is decreasing, so our unknown will be subtracted. The local mean time of sunrise in latitude 37.82 degrees is 07 hours, 10 minutes, 54 seconds. This local mean time of sunrise is on 19th of December, not 20th of December, since 19th is the middle day of this daily page. Let's proceed to step 2. We need to determine the local mean time of sunrise, for the following or next daily page, if the observer is in the west longitude, and the preceding or previous daily page of the Nautical Almanac, if the observer is in the east longitude. Since the ship's position is in the west longitude, let's extract the time of sunrise on the next daily page, which covers December 21st, 22, and 23. So the time of sunrise that we can extract from here will be on the middle day, which is 22 of December. Let's zoom in on this portion of the daily page. Again, we need to find the time of sunrise for this latitude, but it has no exact value in here. So let's extract the time of sunrise in latitude 35 degrees north, which is 07 hours, 05 minutes. At latitude 40 degrees, the time of sunrise is 07 hours, 19 minutes. Let's interpolate again, but this time, I will use FX991ES Plus Scientific Calculator. Once the calculator is switched on, press the Mode button. Select Stat, so press number 3. Then choose this equation, so press number 2. Under column X, enter the latitude 40 degree, and press the equal button. Next, enter latitude 35 degrees, then the equal button. Next, use the scroll button to bring the shaded rectangle along the Y column, in line with latitude 40 degrees. Then, enter the corresponding time of sunrise, which is 07 hours, 19 minutes, and press the equal button. Use this button for the unit of time. It does not affect the value of what we are looking for. Next, enter the corresponding time of sunrise on latitude 35 degrees, which is 07 hours, 05 minutes. Then press the equal button. This is what it looks like in your calculator. Next, press the AC button to save it in the memory. Then, enter the required latitude, which is 37 degrees, 49.41 minute. Next, press the Shift button. Then press number 1. Next choose regression mode, so press number 5. Press number 5 again, and then the equal button. Next, press these symbols button, and replace the symbols of an arc, with the unit of time. The local mean time of sunrise at latitude 37 degrees, 49.41 minutes is 07 hours, 12 minutes, 54 seconds. This time of sunrise is on December 22nd, which is the middle day of this daily page. We now have the local mean time of sunrise on 19th and 22nd of December. However, we are looking for the time of sunrise on 20th of December. In this case, our third step is to interpolate the local mean time of sunrise on the 20th of December. If you do it manually, this is supposed to be the setup. On the left will be the dates, and on the right is the corresponding time of sunrise. The local mean time of sunrise on 20th of December is 07 hours, 11 minute and 34 seconds. Now, before we can determine the zone time of sunrise, we need to apply the observer's longitude, but we need to convert this arc into time. So our next step is to convert the observer's longitude into longitude in time, LIT. This is simple if you have a calculator. Enter 122 degrees, 23.0 minutes, then divide by 15, and press equals. Just change the unit of an arc to a unit of time, so our longitude in time is 8 hours, 9 minutes, 32 seconds. If you do not have a calculator or conversion table, then you need to convert it manually. Divide 122 degrees by 15, the quotient will be in hours. When dividing manually, use the long method because we need the remainder. The remainder will be multiplied by 4, and the product will be in minutes. Next, divide 23 minutes of an arc by 15, the quotient is in minutes of time, then multiply the remainder by 4, to obtain seconds of time. The longitude in time is 08 hours, 09 minutes, and 32 seconds. Why do we need to divide it by 15, and the remainder is multiplied by 4? The Earth rotates 360 degrees in 24 hours, this means the Earth rotates 15 degrees per hour, and in 1 degree of an arc, it corresponds to 4 minutes. Let's proceed to our final step. Calculate the zone time of sunrise. Now, apply longitude in time to local mean time of sunrise on 20th of December. Subtract easterly longitude, and add westerly longitude. Since the longitude is west, we will add the LIT to determine the universal time of sunrise, which is 15 hours, 20 minutes, and 66 seconds. Since we have only 60 seconds of time, let's subtract 60 seconds from 66 seconds. The 60 seconds that have been subtracted, which is equivalent to 1 minute, must be added to 20 minutes. The universal time of sunrise is 15 hours, 21 minutes, and 06 seconds, on 20th of December. Now, apply the zone description to determine the zone time of sunrise. To find the zone description, just divide the longitude by 15, and the quotient must be rounded off to the nearest whole number. The zone description is +8. The sign of zone description for westerly longitude is positive, and negative for easterly longitude. To find the zone time or local time from the given GMT, the rule is, reverse the sign of the zone description. In this case, from GMT to zone time or local time, we will reverse the sign, so we will subtract the zone description. The zone time or local time of sunrise is 07 hours, 21 minutes, and 06 seconds, on 20th of December. On the other hand, when finding GMT from the given local time, apply the sign of zone description. For sunset, do the same procedure as for determining the sunrise. That's all for now. I hope you found this video helpful. See you in my next video. Thank you for watching. Bye.